I've recently updated the schematic and PCB for my 286 system board, and I thought I would quickly walk through some of those changes for those of you that are just kind of paying attention to how that system, how that board is evolving over time here. Here is the current schematic, and maybe I will flip over right away to just show the PCB. And maybe even more helpful than that is a 3D view. So I'll start with this and just kind of show you. This is the version 0.20, and so I'm coming from version 0.11 to 0.20, and I've made some changes in this that are hopefully helpful changes, and let me just talk through some of those. First things first is I've removed the need for the external clock and power card that I've been using. So typically in the upper left of this, I've had this PCB up here that's providing maybe clock signals coming in so that I can single step or run through a slower clock or a faster clock, whatever it might be, and also giving some power distribution capabilities. So to support that, one thing I've done here is I've actually put an onboard crystal. So I have a crystal along with a couple of capacitors that I can now feed a crystal clock right into my clock generator. And that means I do not need a separate board to do that. And just this tiny amount of space will give me my clock that I need. And so I'll come in here with a, let's say, a 16 megahertz crystal, and that will give me what I need for the board. Now I still did leave a header, and there is a header that I have in the system that I can still tie into a clock signal and bring in that clock. And if I come in here, if I wanted to use an external board, I have this header, and it would be header 22 that I can bring in a clock from elsewhere and come into this, really plug in right here. And that will come in as clock in if I bring it in from my external board. And the clock generator, that clock in would then go to this pin 5, which is my clock in if I'm using an external clock. And if I don't want to use that, I just simply don't connect it, and instead I need to make sure that this pin 6 gets changed. So I have a jumper that I can either set it to be internal or external clock depending on which way I jump it. And if I say to use the crystal, basically, then it's going to use X1, X2 here, pin 7 and 8, that it's going to pull from my crystal. I can still go to header 22 and plug in, and let me just go find header 22 on here real quick. So if I go to my components and I look for header 22, that is sitting over here at this point. So I still have this little header. I can plug in my external card to it if I would like to do that, but I no longer need that card. So that's one change that I've made. Another is that external card also supported reset. So I could press a reset button, or when I power on, it delays and holds down the reset for a period of time. And someone had suggested maybe try out a DS1232 to do that reset functionality. And so that is what I've done. You will see that down here now I have a new IC on the board. It's a DS1232. With that, I have a bunch of different jumper selectors around it. I've not used this before, and I imagine there's going to be some trial and error that I'm going to do with it. But what I did is in the schematic, when it comes to the 1232, I have some options. And so some of these options basically let me pull things high or low based on, for example, what type of delay do I want to have. Also, am I going to use a reset, or actually one of these is an inverted reset coming out of this. I'd have to look up on the data sheet which was which, but I give a jumper which of those do I want to have being used as my reset for the rest of the system, etc. So that allows me to come in, set it to that. It flags it with this res sharp or res B, which then gets used over here. But I've got the 1232 set up here. I have set it up so that I can get in here and change things from high to low for many of these different values that are configurable on the chip. And maybe I can just pull up that data sheet here real quickly. And so here is the data sheet for that DS1232. And you can see the pins here, 1 through 8. I'm using this version of it, the 8-pin DIP. But I come down here and there's a push button reset input. So back in my schematic, you'll see that the push button reset, I actually have that tied to a switch that I've now added to the board. So my system has not just the DS1232, but it has a reset switch now built onto it. So if I press that, that'll reset the system. Additional pins here, there's a time delay set. There's a what type of tolerance do I want to have. The nice thing about this DS1232, if it detects a low voltage by 5% or 10%, it can do an auto reset. Basically, another thing that it can do is this strobe input for a watchdog, if I remember if that's the right pin here. So with the watchdog, I can tie that to one of my address lines, and if it sees no activity on it in a certain period of time, it basically resets automatically also. So I don't know how I'm going to use all those exactly in my configuration, so I'm giving myself some flexibility with these pins. So if I go look at this strobe input, you'll just see that I'm giving it a pair of pins here, and I can later experiment. Do I tie it to A0 or A10 or something else in my system that makes sense to keep this watchdog continually updated so that it doesn't reset unless it needs to. That's been added, and that is this addition here along with the button here and all of these extra pins connecting to that so that I can experiment. Something else you'll notice is I added a pair of banana plugs up here. I've not added an ATX power connector yet. I am at some point maybe going to reformat this into an ATX format of a board, and at that point I would put on an ATX power connector. But for now I'm going to support either a DC barrel jack type of connector, or I have a screw terminal type of connector, or one of those quick connect type connectors could go here. And my preferred by far is the banana connector, so I can just slide 2 banana connectors directly from my power supply, my benchtop power supply, into it here. That is now right on board. So with all of those changes, I no longer need that separate card. I can run banana plugs right into this. One thing I did not put on here is a power switch, which is fine. I'm just going to use my benchtop power supply for now for that. If I decide later, I maybe will add that along with that little relay. But we'll see if I end up doing that or not. You're also going to notice that I used to have a bunch of bar graph LEDs. All of those have been removed for the address and data. I've kind of found that now that the system is kind of running and doing what I need it to do, I really don't get any value out of those. And I also used to have some LEDs down here that were showing different outputs of the processor signals. Same thing. But what I did do is I put them up here as headers. So if at some point I want to slow down my clock, I can flip to my external oscillator and use my other card temporarily. I can also then reconnect through these headers all of those different LEDs and do a slower debug if and when I ever decide to do that. So the functionality is there. It's just I'm not going to take up space on the board itself to do it. I also had on my last set of videos on this board, I had a separate little daughter card that I had just put up here that was a PS2 keyboard auto reset to support a newer keyboard that I have that doesn't work unless the host, in other words my system, provides an acknowledgement on startup. So that little circuit I built right in now, so all of that keyboard functionality is native to this board. I've also added internal bus pull-ups. So all along here I can basically pull up my values that are coming out for address and data. And I found that on a previous system, the breadboard system, that made a huge difference just on keeping those signals clean. So I put it in here optional. I can choose to use it or not use it, but I do have internal bus pull-ups. And to the right I still have my external bus pull-ups or pull-downs with a jumper. These I just set to all be pull-ups. I don't have a pull-down option. I think pull-up is really all that I need at that point. I did add some additional standoffs across the board just for a little bit better support. I also took the size of my traces for power and doubled them from what they were before. So if I go into my design rules, I'm now up to about 1 millimeter for the power. That'd be VCC and ground. Everything else is 0.254, and I was running approximately 0.5 previously and was running into a little bit of issue with voltage drop, and I'm trying to maybe help with that. So I increased that up to 1 at this point. I increased the via diameter and the drill hole a little bit. So anytime power has to be basically put through a via, it's going to be a little bit larger, but the overall power tracks are going to be larger. And then in addition to that, I added fill. So there's copper fill wherever there aren't traces, which I said fill the entire top with VCC and fill the entire bottom with ground. And you can see here where it got filled in. All this other stuff, it didn't automatically fill it in. You know, I'm not sure what EZ80A uses for its logic to fill that in, but probably not accessible because of the traces, so it couldn't get to these other areas is probably why there's nothing filled in there. But I figure at least that this is probably helpful that it can now get VCC through all of this, all around the board. You know, so it's closer to getting into, for example, down here, I can now get into my ISA slots with a cleaner power. All these things down here now, maybe hopefully we'll have a better power access to them, and when they aren't coming down to this, at least there's this 1 millimeter trace now. And then the same thing on the back, I could look for those 1 millimeter traces or see if things are getting a nice ground wherever they might be using them. So between those two things, I'm sure I could try to even make this larger yet, but I'm going to try it at this 1 and see if 1 millimeter and that extra copper fill, what kind of difference that might make. So I think those are the changes. This has been fully routed, and I suppose at this point I could, well, a couple of things, you know, making sure there are no DRC errors, which I don't have any at this point. So actually I can go back here and take a look. That's clear. I could real quick check and see cost of fabrication. So if I was going to order this board with those changes, it looks like I have an $8 coupon right now, but $30 for 5 of these. So the boards are $6 a piece. It still is a 2-layer board. And then you can see the overall dimensions, which should be smaller because overall you're going to notice that I pulled things in tighter. All of this is much tighter than it was before. So it's a smaller board than my previous board. I guess things that I've done, I did the crystal, I did the reset, I have the banana plugs on there. I've taken out a lot of the LEDs and put in headers instead. I have my PS2 auto reset circuit. I have the internal bus pull-ups. I have additional positive negative little headers that I've sprinkled across the board just because I find those handy for plugging in a scope or doing something else. Or if I got to a card, I could even run supplemental power from that up to the card through these connectors, or solder in some wires. I have the additional standoffs throughout the board. I've doubled the size of my VCC and ground traces, and I've filled in as much copper as I can and still be on a 2-layer board. So that's where I'm at, and I don't think I'm going to actually order this PCB at this point. I'm going to maybe sit on this for a little bit for now. The one I have is working well, and these are just some niceties that I've made for changes that definitely aren't required for what I've been working on. This is ready, so if I want to do some more changes to it, or if I decide at some point I might order this anyways, maybe $30 plus $20 shipping isn't so bad. It ends up being $10 a board. It might just be a nice step to see if my power doesn't drop as much when I get down here to the lower right. That might be worth ordering anyways. But that's the update I have. That's taken me to PCB version 0.20, and we'll see how that checks out here as we move forward.